Hey everybody, this is Mr. Patterson here taking a look at our AP Statistics Chapter 1, Section 1. We're going to be talking about analyzing categorical data. So we have a few objectives today, but the most important thing to keep in mind is that we're really focusing on categorical data. So we're going to be displaying them. What kind of graphs do we use? We're going to identify what makes some of these graphs deceptive and therefore things we should try to avoid. We're going to calculate a couple of different things. We're going to calculate marginal distributions, and we're also going to calculate conditional distributions, both of which for two-way tables, and we'll explain what that means as we get going. And then the last thing here, probably the hardest thing in this section, is to describe the association between two categorical variables. And the reason it's more challenging is because it's not evidently obvious what it is that we are supposed to be doing when we describe that association. So when we have categorical data, we know that it's when we respond to a question with a word. All right. So in this particular case, we are looking at what type of music does the radio station play. We have adult contemporary, adult standards, all the way through with all these different options here. So when we look at them, we have to think to ourselves, okay, well, we could look at them as frequencies, meaning counts, or we could look at them as relative frequencies, which puts them into percentages. Generally speaking, having your categorical data in percents or even proportions is preferred. The reason being it's easier for comparison purposes. But if we are going to be displaying these in some kind of graph, either form is okay. The variable that we're talking about is the format of the station, and the values that it takes, well, those could be the counts or the percents. Now, what we want to do is we want to make these into graphs. Now, there's only really two, well, I shouldn't say that. There are three types of graphs that we could make for categorical data. The first two are bar graphs and pie charts, which you've seen before. So I can make a bar graph of the first chart, which looked at the frequency. Nothing really obvious here that's any different than any bar graph you've ever made all the way back from, say, third grade on. We have our individuals here on the horizontal axis and our frequency here on the vertical axis. And we can make them into a pie chart as well. Pie charts generally are not recommended for students to make in AP Statistics because it's difficult for us to make them with any kind of accuracy, especially when we have so many different categories as we do here. A couple things you want to be mindful of. Make sure on your bar graphs that your bars are equally wide. And it says here, don't try to get fancy with the bars. Don't do any kind of hatching or shading. That's just not necessary. Just label it well and make it easy to read. If you avoid those things, you'll be fine. So the next part we're going to talk about is two-way tables. So before we get into talking about marginal distributions, let's just kind of make sure we're clear on what a two-way table is. A two-way table describes two categorical variables, one organized in a row and one organized in a column. So if we look at this situation here, we're looking at young adults by gender and chance of getting rich. We have two categorical variables. I could ask you, what's your gender? That's one categorical variable. And what's your chance of getting rich? And we have right here, all right? So we have two categorical variables represented in this two-way table. That's what it's referred to as, all right? When we are looking at these two-way tables, we always want to put in totals. So we have here the row totals, and we have down here the column totals. When it asks the question, how many adults were surveyed? Well, that's referred to as the table total, 4,826. And I could get that if I added the two column totals together, or if I added all 5 of these row totals together. They should always add up to the table total, and that's something you should check when you're adding up your totals to make sure you don't make a silly mistake there. Now, when we're talking about marginal distributions basically means we're just looking at one of the categorical variables. And to help you understand or to remember what a marginal distribution is, think margin. So if I think about the margins of a table, if I go back a slide, I know this table, this total here of the rows, that represents a margin. But I could also have a margin down here. It all depends on which variable it is that I'm trying to get the marginal distribution of. So the definition up here, the marginal distribution of one of the categorical variables in the two-way table of counts is the distribution of values that the variables among the individuals are described by the table. And it says percents are often more informative than counts. And that's generally a rule of thumb that we want to stick with there. We want to keep always looking at the percentages, or again, as the proportions, not the count. So how do we do it? Because we use the data in the table to calculate the marginal distribution in percents of the rows or the column totals. And again, you have to read carefully to make sure you understand which variable it is you're looking at. And then you're going to make a graph to display that marginal distribution. And that graph generally is going to be a bar graph. So here's that same two-way table from before. And it says up here, examine the marginal distribution of chance of getting rich. Chance of getting rich. So basically what that means is gender doesn't matter for this scenario. We're just going to take these totals here of the individual rows, convert them to percentages first, and we see here 4% say almost no chance, 14.8% say some chance, etc. on down. These should add up to 100%, by the way. And then once we have those percentages, we just put them into a bar graph. Nice and easy to see, but it allows us to gain a little bit more of a visual understanding of what the relationship is for that variable there. And we could have done a marginal distribution for gender. It doesn't necessarily make too much sense in this case, but we could have done the same thing. Now, that's marginal distribution, looking at the margins, looking at just one of the categorical variables. We could also do an analysis comparing the two different variables. That is what's referred to as a conditional distribution. It says a conditional distribution of a variable describes the values of that variable among individuals who have a specific value of another variable. Sounds confusing there, but basically what we're going to be doing is we're going to be taking one of those values of one of the categorical variables and just finding those percentages there. So we select the row or column of interest. Then we use the data in the table to calculate the conditional distribution, again in percents, of that row or column. And then we make a graph to display the conditional distribution. And if we're trying to compare, which is often what we do, we can make side-by-side bar graphs or segmented bar graphs. Side-by-side bar graphs are certainly something that you've done before when you were comparing multiple categorical variables. Segmented bar graphs, probably a little bit new, but not too hard to make. So again, let's go into our same two-way table that we had before. And it says calculate the conditional distribution of opinion among males. Okay, so the condition is that they must be males. So we're focusing just on the male column right here. Then it says examine the relationship between gender and opinion. Okay, so we start off by making our conditional distribution. Now you'll notice that we're, again, only on the male column. So the percentages, we take the 98 and we're only dividing it by the total of the males. So the 98 divided by the total of the males. And then we do the same thing for some chance, 50-50 chance, etc. on down. Then we're going to do the females as well so that we can do the second part of this question, which was examine the relationship. And if we look at them here, we could do a little bit of analysis by looking at just the percentages in the table. But often people like to see graphs so they can quickly and easily see. So here is the segmented bar graph. Now, what are we actually looking at? We see here the bar graph for males goes all the way up to 100%, and the bar graph for females goes all the way up to 100%. That's because it's accounted for all 100% of the people in this study, right? So 4% of males, that's this light blue portion down here. And then from 4%, we add 11.6%. That's this green percent. So it's going up to 15.6%. And then it goes up and up and up and up for each one. And then we do the same thing with the males. Now, to examine the relationship, what we're basically doing is we're comparing the blue section of males and females, the green section of males and females, etc. on up. And if we look at it, we're trying to ask ourselves, do we see any major differences? Are there any categories for males that's drastically different than females, or vice versa? And in this particular case, not really, okay? Not really much of a difference there. So when we're asked the question, can we say there's an association between gender and opinion? Well, generally speaking, because we're looking at the fact that the colors almost match, not exactly, but pretty close to the same, that there is no association. So getting back to that last bullet point in our objectives that we had at the beginning of this lesson, how can we establish whether there's an association between them? We compare the graphs. And if it were a side-by-side bar graph, we'd be comparing the side-by-side bar graphs. Now, we're not necessarily coming in and saying that there's definitively no association, but what we are saying is that based on this preliminary analysis, there doesn't appear to be an association. We'll get more formal with that analysis later on in the course. All right. And also, a word of caution, if there appears to be an association between the two variables, meaning if the colors did not match up very closely, then that would be a situation that we want to say there might be an association, but that doesn't mean that one is causing the other, because there's always other lurking variables that we're not studying here. All right. Maybe is socioeconomic status of people in this study. Maybe it has to do with the the amount of education their parents receive. There's lots of other variables that could play into this example here. So that's it. Okay, we looked at our categorical data. We talked about which graphs to make for categorical data. We talked about what are some problems with categorical graphs that we have to be mindful of. We talked about two-way tables with marginal distributions. We talked about two-way tables and calculating conditional distributions, and how to describe the association between these two categorical variables. So pretty quick lesson, but three really important things here: marginal distributions, conditional distributions, and describing the association. All right, so make sure those three things are very clear to you, because it's going to be very important as we move forward in the course. All right, that's it. See you guys next time.